which basically is just going to give you an overview of some of the material that we're going to cover in Chapter 2. So Chapter 2, I guess I would say the way to describe it is getting the picture. What we're trying to do is find ways to display data, and we're after the big three. The big three would be the shape of the data. What is its shape? Is it got one mode, two modes, three modes? Is it mound-shaped or bell-shaped, which is what we are hoping for when we examine data? What is the center of the data, meaning where are most of the data values clustered? Around what variables or values are most of the data values clustered? And the last is the spread. The spread is really talking about the width of the data, or how much variability there is within a given data set. So again, getting the picture is the topic, and then I wanted to just kind of escape here from the PowerPoints and talk about one array of data, and that is the U.S. historical budget tables. And for anybody that's interested in this topic, because it is in the news a lot, all you need to do is go into your browser, and in the search engine, type in U.S. budget historical tables. Now, here is fiscal year 2012 hysterical. Yeah, that's really probably the better word. Anyway, historical tables for the budget of the U.S. government. So I'm going to select that. And we've got the seal of the U.S., Office of the President, Office of Management and Budget, and we've got these different historical documents, or the budget. And I'm going to click on page 25 because I know that's where it starts. And, you know, a topic that's been often in the news is the amount of our budget deficits, recent budget deficits. Now, what's kind of interesting is that you can look up in the historical tables how much our budget deficits or surpluses have been in various years. And it goes all the way back to 1789. And from 1789 to 1849, they kind of encapsulated all of those into one period, and they've got receipts of $1.160 million, outlays of $1,090 million, and it shows that at the end of that period, we had a budget surplus of 70. It's a surplus because it's not a negative. 1850 to 1900, they combined those years, and here's the receipts, the outlays, and for that 50-year period, and that included the Civil War, there was a deficit of $991 million. And then we can scroll down, and it goes on year by year by year. And you can, if you kind of go through this, you'll notice that, in fact, let me go back up a little because it's kind of interesting. If we look through these budget totals, it looks to be that it was about 1931, which was the middle of the Great Depression, when we began incurring budget deficits. So no surprise there. And then, well, it looks like our last deficit was about 1946, and then we had a couple surpluses, another deficit, a surplus, a deficit, a surplus, and then we'll scroll down to more recent years. Oops. My left mouse button doesn't work, so I have to it takes me a little bit of time, so if you could please be patient with me. Anyway, here it is from 2000, the year 2000. This column, this third column, represents the budget deficit or surplus. You can see we had a $236 billion surplus, then a $128 billion surplus, and then everything is negative. And prior to that time, everything was negative too. We had budget deficits. And you can see, for example, back in the 80s, we had budget deficits that were $200 billion, $150 billion, $290 billion in 92. and then 160, and then 2002 we continued our budget deficits, 157 billion, 377 billion, 412. 412. When we had that budget deficit in 2004, I can remember how badly that was looked upon because it's such a huge amount compared to any prior budget deficits. And then as we keep going, 2005, 6, 7, 8, and then all of a sudden we hit 2009 and our budget deficit not only got bigger and a lot bigger, but it skyrocketed. You could just say roughly $1 trillion in budget deficit was added from 2008 to 2009. And then if we go to the most recent years of that budget shows, it shows, for example, that in 2010 we had a budget deficit of 1.3 trillion. The estimates for 2011 is 1.6 trillion, then 1.1 trillion. And still the estimates are more than, well, at least double or more than what we've ever had in our past. So how in the world would you like to examine this data? And how would you display it? We certainly don't want to look at all that raw data because that's just too overwhelming. And so we need to figure out a way to summarize the data in some kind of a display that makes it more meaningful. So just to review, there's a few definitions that I try to give you in every Lifeline, just so that you will be comfortable and starting to learn some of the terminology of this class. A data set, well, as it tells you here, it's a particular collection of data values as a whole. An observation is each individual data value. The subject, well, the subject is a particular item or measurement of interest. And it says, example, an employee in your company. Well, often a subject might be, or individual, might be somebody's pay or wages or the unemployment rate, or for example, the deficit for a particular year. And then the variable, well, that's a characteristic about the subject or individual. Okay. Now, again, as a reminder, you're going to also need to be getting used to, let me turn off my camera here. You're also going to need to be used to getting used to some of these variable designations. And I can't remember what chapter, it might have been 3 or 4, that I gave you a list of some of the variables so that you could get used to the notational form. But you might remember, first of all, from the last Lifeline, that the population is described by parameters. And the parameters for the population might include things like the population mean, which is designated by the Greek letter mu, and then we can also look at something called the population proportion. Or, again, those are parameters. Parameters are descriptions or measurements about the population, whereas statistics describe our sample or provide measurements about our sample. So capital N refers to the population, the small n refers to a sample, and the statistics that we're going to be working with fairly frequently is, for example, the sample mean. And the sample mean is shown as X bar, X with a bar on top. Again, it just means the average or the mean. Okay. Where to find statistics? Well, if you want to look up statistics, Lord knows there's millions of places that we're inundated with all these different numbers. But just some of the common ones, particularly one I wanted to bring to your attention was something called the Statistical Abstract of the United States. If you have never visited or looked at the Statistical Abstract of the United States, it's a pretty amazing collection of data. It's just a huge database, and the data might be a year or two old by the time it's published. But if you want to know anything about the United States, like if you want to know what is the number of cell phones in the United States, what is the number of automobiles in the United States, what is the average number of bathrooms per house, it'll be in the Statistical Abstract. It just has an unimaginable list of data that describe the United States economy. So we're talking here about displaying our data. As we get started in this class, you're primarily going to be working with one variable, and when you have one variable, the displays that we use are ways to describe or display the data. Could be histograms. You can also use descriptive statistics, and then something called the frequency distribution. I think I did that in the last Lifeline, but I'm going to do another one. If you have two variables, well, often we're going to be using two variables. And two variables, well, that means in order to display them, we can do what is called a scatter plot, which plots the x variable on one axis and the y on the other. And the purpose that underlies that is to determine, are these variables related to one another? Is there any correlation between them? Now, if there is a correlation, the next question is the correlation positive or negative? Meaning as one goes up, does the other one also go up? Or if it's negative, then obviously when one rises, the other one would fall. And when we get around to chapter 13 in this class, we're going to do what is called simple regression analysis. And even though it's all the way into lesson 13, I'll give you a real quick preview of it in this Lifeline. The very last chapter in your book that you're going to cover is multiple regression. And that's used for when you have more than two variables. And that's a pretty fun little end to the class. Although there are also ways when you have more than two variables to display them through data mining and econometric modeling. Those are topics that are above and beyond the scope of this course, so don't worry about those. Now, in a moment, I'm going to go back to the bank waiting times that we referenced in the first Lifeline. And again, just keep in mind, the whole goal of these displays is to determine the shape, the center, and the spread of the data. I'm also going to use two variables. That was my two variables example, just so we can do the same thing. And then I did want to mention that when you're using qualitative data displays, qualitative, remember, those are things that are categorical or nominal, things like male, female, freshman, sophomore, junior, senior, business major, econ major. Then you can use things like bar charts, pie charts, and also Pareto charts. And I'll leave those to you. But again, the whole goal that underlies those data displays is still the big three. The shape of the data. Has it got one mode, two modes, three modes? Is it mound-shaped or bell-shaped? Where are most of the data values clustered? What is the spread of the data? Is it really widely distributed, or is it narrowly distributed? And we're also going to use an example that I borrowed from your text, and the example is about the sales of home in Florida, which have pools. And the reason we're going to use this particular data set is because I'm going to demonstrate to you the way to display two variables to determine if there is a correlation between those variables, meaning that there's some relationship between them, or maybe there's no relationship. So let me leave this PowerPoint, and I'm going to go ahead and return to my Excel spreadsheet. Okay, now, this is the bank waiting times. Hopefully you remember this spreadsheet that we did last time. And I left it kind of the way it is here with no grid lines. But I wanted to remind you that if you want to see it with grid lines, which makes it easier to read, then the tab you need, which may not quite be showing on this video, is the Page Layout tab. And then you go over to Sheet Options. You click View Grid Lines, and that puts the grid lines in. And then right below that, click Print Grid Lines, and that will, when you use the print command, those grid lines will show. Otherwise, they won't show. Okay, so let's see, bank waiting times. I got to do something with these times. So let's see. I'm going to Add-ins. I'm going to Megastat. I'm going to go to, well, let's do descriptive statistics. Now, we're not quite ready for descriptive statistics. That's going to come in the third chapter. But what the heck, it's right there on the list. So, in this particular section, descriptive statistics, there's three selections that are the default. The mean, which is the average, the the sample variance and standard deviation. We'll talk about what those mean later. The minimum, the maximum, and the range. So that's the lowest value, the highest value, and the range, the difference between the maximum and the minimum values. And so I've got to put my data in. So I've got to click in my input range, and then I'm going to highlight this column. Remember, there were 100 waiting times for banking transactions. Okay, so that's in there, and now I'm just going to click OK. And I've got my descriptive statistics. The first thing it says is, well, there's 100 observations, or 100 different times. The mean time was 5.46 minutes. The sample variance and the sample standard deviation are given. I'm just going to defer those for another time. The minimum value was 0.4 minutes. So 4/10 of a minute was the least time somebody waited in between for their transaction. The maximum amount of wait was 11.6 minutes. I wouldn't have liked to have been that person. But anyway, the range of these wait times is 11.6 minus 0.4, which tells you the range of time is 11.2 minutes. So now I'm going to go back to my wait time. I'm going to go back to Megastat, and I'm going to do a frequency distribution. And since it's numeric, I'm going to do a quantitative frequency distribution. And I'm going to just pick 3 displays here. Histogram's already marked, so I'm going to check polygon and OG. And then what I've got to do is, well, I've got to enter my data. Okay, I'm having a little problem. My left mouse is broken, so I'm going to have a little challenge here getting through this. I'm going to get it fixed tomorrow. My left mouse buttons will definitely be fixed tomorrow, but let me get through this hopefully today. Okay, so I'm going to highlight this column. Oh, shoot. I can't highlight it until I get the Megastat up here. So back to that. Frequency distribution, quantitative. I've got all 3 checked, and now I'm going to enter this column of data. Okay, and then I'm going to click OK. Okay, so Megastat automatically will produce a frequency distribution, and they will select the number of classes rather than you specifying what number of classes. And in this case, they've gone from 0 to 1 minute, 1 minute to just less than 2, 2 to 3, 3 to 4, etc., all the way down to 12. You've got the midpoint of each interval. You've got the width is 1 minute. And then you've got the frequency column. The frequency here shows, well, the greatest number of wait times were 17, and they were from 4 to 5 minutes. Yeah, 15 was the second from 5 to 6 minutes. And then you've got your histogram, which is really just a bar chart with the bars with nothing in between the bars. They're just adjacent to one another. And this, again, is another way to view or display that data. And you can see, remember, we're looking for shape. Well, this has pretty much got a mound or a bell shape. It's not perfectly symmetric, but it's a nice shape distribution. And, well, we're looking for where are most of the data items centers. Well, that's going to depend on what the highest bars are. You can tell these are the 3 highest bars. So most of the data items, or much of the data, is centered between 4 minutes and 7 minutes. And we could say maybe, I don't know, it's a little rough to calculate the percent, but that's actually in the frequency distribution. From 3 minutes to 8 minutes maybe is about 75% of the data. Then there's the frequency polygon. The frequency polygon is just kind of a similar way to display data, and basically what it does is it takes the histogram and it puts a dot in each one of the center of each bar, and then it plots the line graph of those centers. And so this is a kind of interesting representation because it does show you, well, it is kind of bell-shaped. It's a little bit leaning more to one side. It's not perfectly symmetrical again, but it also shows you that it's very clear that 17 was the highest frequency, and it appears that happened between 4 and 5 minutes. Okay, another is the ogive. And the ogive, that actually plots the cumulative frequency, which is the next to the last, or the last table, or the last column in the frequency distribution. So let me just scroll up there for a moment. Yeah, it's the last, it could be either the last two columns. It's the cumulative frequencies. And if you look at the ogive, well, what in the world can we tell from this? Well, you could say 50%. Well, 50% is kind of an important percentile. It's also the median value, but basically you can find 50% of the people weighted, I'm going to guess here, from about 5 1/4 minutes or less. So that means 50% weighted longer than 5 1/4 minutes. We can also look at 75th percentile, or 75% of the people, customers weighted from, no, this one's a little tougher to see. I'm going to say roughly 7 minutes. 75% of the people waited less than 7 minutes. That means 25% must have waited more than 7 minutes. So those are three easy data displays that you can get from just going to Megastat, or frequency distribution, and quantitative. That will take you there. Okay, so now I also did a hypothetical. Oh shoot, I have to get rid of this now because that was my practice one. So let me get rid of this and kind of go back to where I was. Uh-oh. Okay. Well, let's just ignore this thing. Let me just move it out of the way. There we go. Well, it's going to move. Okay. I kind of made this up and I said, okay, let's say that we have 9 females and 10 males in a statistics class. And like our class, the grades, let me clear this too. The grades on the exams, if you recall from the syllabus, go up to a maximum of 60 points. Now I'll probably be adding some extra credit on that, but let's just kind of ignore our tests now and just talk about this as an example of, let's say, 9 females who took a statistics exam, and these are their test scores, 44 down to 58, and the number 1 designates females, and number 2 designates males, and they begin at 48 and end at 36. So how can we display this data? Well, first of all, I have to tell you, the more data, the better the display, but I'm just going to confine this one to these 9. And I'm going to go to add-ins, I'm going to go to Megastat, I'm going to go to, well, do I want to do a frequency? Yeah, I'll do a frequency distribution, quantitative, and I'm going to highlight the first 9 items, which are my hypothetical female grades, and I'm going to mark histogram. I think I'll just do a histogram for this, and click OK. Okay, now, this is kind of an interesting output, and again, it was just hypothetical. This did a frequency distribution. The width of each interval was 5, from 30 to 35, 35 to 40, 55 to 60, etc. Gives you the midpoint of each interval, and then it gives you the percentage. And if you look here, you'll notice that from 30 to 35 was 22% of the scores. From 40 to 50 was 33.3% of the scores, and from 55 to 60 was 22.2%. Now this was just again a hypothetical example, so I just threw some numbers in here. But when you look at the display, you've got 3 bars that are very high, and it looks like, well, there was a big gap. So here's our 22% that scored from 30 to 35. Here's our 33 1/3% that scored from 45 to 50. And then here's our, again, our 22.2% that scored from 50 to 60. If you were going to describe this data display, you would describe it as being trimodal, meaning there were three frequencies where the most observations occurred. Of course, this is a really small data set, so this doesn't have a whole lot of meaning, and it's just for illustration purposes. So let me go back to my two variables, and well, let's try something else here. Let's do again, oops, a quantitative data display, but this time I'm going to use all the scores. And I think I'm also going to order or request a polygon and an OG. And again, all I have to do is highlight these values. I have to input them. All I do is just do that by highlighting the table and clicking OK. Well, now this looks a little better. I've got 19 values now. And okay, it looks like there's a certain proportion, 15.8% exactly, that were from 30 to 35, so they didn't do too well on the test. Then I've got that same percentage, that 15.8% that got between 40 and 45. And the highest frequency was there were 5 students out of the 19, or 26.3%, that scored from 45 to 50. So this histogram looks a little better than the last one because it's got one mode, and the majority of the information is here. But then again, it starts high, goes low, and then it's rounded. So you might say, well, there's actually 2 modes there. So that might be a bimodal distribution, or might be referred to as a bimodal distribution. And when you examine, for example, the polygon, it's real clear. Here's a cluster of results that fell within this range, and another cluster of results that fell within this range. So clearly, we would refer to this distribution as being bimodal. Now, I'd like to go to the data set that I mentioned before, and I don't know where I pulled this from, but I'm 99% sure it was from your textbook. And what this data set gives you is Florida pool home data, meaning the sales of homes in Florida. It gives the price in thousands of dollars, the square feet, the number of bathrooms. It gives something called the niceness rating. Niceness rating. It looks like it goes from 1 to 7. I wonder if there's a 0 in there. Well, I'm not going to look because my mouse button's broken. But anyway, I don't know. What do you suppose a niceness rating does? Maybe it refers to the fact of, is the property well maintained? Is it freshly painted? Is it up to date with up-to-date appliances and plumbing fixtures and all that kind of thing? And then this one, this column here, you'll notice has just zeros and ones in it. And we refer to that as a dummy variable, or we can also refer to it as a proxy variable. It's not anything you need to worry about now, but I just thought I'd mention that this is a way to take qualitative data and give it a numerical value so that we can analyze it statistically just like we would any other numeric value. So clearly, if the home sold had a pool, it was designated with a number 1. If there was no pool, it was designated with a 0. So anyway, we're not going to worry about this column anyway, but I thought I'd mention it. And we're going to look at these 2 columns, price and size. Would you expect there to be a relationship between the selling price of a home and the number of square feet in that home? So would that relationship be positive or negative? Well, hopefully it'd be positive. I mean, logically it would seem that it would be a positive relationship, meaning the greater the amount of square feet, the higher the price would be. So let's see if that's true. Megastat will allow us to calculate, well, first of all, present a scatter plot of these 2 variables to see how they're related, and a few little extra items. So first of all, I'm going to go to Megastat. I'm going to scroll down here to correlation, and then if you notice, one of the selections is a scatter plot. So that's really what I want to do. I want to display 2 columns of data, or 2 variables. Now, the horizontal axis and the vertical does the horizontal axis typically have, or what does it display? Would that be the independent or the dependent variable? Well, of course, you probably remember that the independent variable is plotted on the x-axis. So for these two, which is independent? Absolutely, it's size. So let's, in fact, let me start with this. I'm going to input this column as the independent variable to be plotted on the x-axis. And it looks like we've got about 80 sales here. Okay, so that's in there. Now the vertical axis, well, that's where we're going to put the dependent variable, and the dependent variable is going to be the selling price. And the selling price, again, is going to depend on the amount of square feet. So I'm going to scroll down on that one. Okay. Chart title. Well, the chart title is going to be square feet. I'm going to say versus price. And you'll notice that the default plots a linear regression line. Now, again, we're not going to talk about linear regression until we get to about chapter 12 or 13. It's really one of the most interesting applications in this class. And let's, for now, though, not worry about that, but we're going to accept that default selection and click OK. Okay, input range contains missing or invalid data. Well, when that happens, sometimes I need to tell you now that Excel or Megastat will not accept the label of a column. So I'm going to redo that. Okay, I'm going to take those data values out, take the other data value out, and again, I'm going to input my horizontal axis, my independent variable square feet. I'm going to highlight that column, but I'm not going to highlight the label. Let's see if that'll do it. Now, I'm not able to tell you when Excel will include a label and when it won't. So if you ever have it say it's input missing or missing data input or missing values, then make sure you don't highlight the label, and that'll probably fix it just fine. So I'm highlighting that sales price, which is our dependent variable. Okay, there we are, number 80. Okay, I got my chart title. It's going to plot the regression line. I'm going to click OK. Oh, there we go. So here's our data display. All these dots make up the scatter plot. And it's really obvious that this is an upward sloping relationship. Now, I know you got the line there, but just ignore that line for a moment. If you just looked at the way these points are distributed, they're distributed in an upward pattern. So that means it's a positive relationship. Square feet is positively related to price. And then this line that's plotted in there, well, you could call it a trend line. In other words, what it does is it tries to find the line that minimizes the differences in these points to get the closest or best fit in between these points. And that's what this equation tells you. This is a regression equation. But the main thing I wanted to demonstrate with this is that this is how you would display two variables. And you use a scatter plot. And again, the way you generate this particular display is by going to Megastat. You scroll down to correlation and regression, and then you click scatter plot. Okay, so I wish you good luck with chapter 2, and things are relatively easy at this point. They're going to become a little more challenging, and I'll see you for chapter 3.